Hi everyone, what a good day. Today I'm going to introduce what is hydraulic system. Hydraulic system is a mechanism operated by the resistance offered or the pressure transmitted when a liquid is forced through a small opening or tube. Thank you.
Hi, Bay.
Hi.
Bay, do you know what's a hydraulic system?
Hydraulic system. Hydraulic system can be found today in a wide variety of applications, from small assembly processes to integrated steels and paper mill application. Hydraulics enable the operator to accomplish significant work with a minimal investment in mechanical linkage through the application of the Pascal's law, which state Archana.
Hi, I'm Archana and today we're going to talk a bit about how hydraulics works. So the basic rule of using hydraulics is the Pascal's principle, which states that pressure exerted on a fluid is distributed evenly throughout the fluid. Hydraulics uses incompressible fluids so that applied pressure on one end is equal to the desired pressure on the other end. The fluid is almost always an oil of some sort. A simple hydraulic system consists of two pistons and an oil-filled pipe connecting them. If you apply a downward force to one piston, then the force is transmitted to the second piston through the oil in the pipe. Since oil is incompressible, the efficiency is very good. In fact, almost all of the applied force appears at the second piston. The good thing about hydraulic systems is that the pipe connecting the two pistons can be any length and shape, allowing it to pass through all sorts of things, separating the two pistons.
I'm going to talk about three types of hydraulic pumps. The first one is the hydraulic gear pump. A gear pump is used in many hydraulic systems. It has few moving parts and works smoothly and operates pressures up till 250 bars. The second type of hydraulic pumps is the hydraulic piston pumps. The hydraulic piston pumps can handle large flows at high hydraulic system pressures. Typical applications are mobile construction equipment, marine auxiliary, metal forming, and machine tools. In these pumps, the pistons accurately slide back and forth inside the piston cylinder. In these pumps, the pistons accurately slide back and forth inside the piston cylinder. And the sealing properties of these pumps are amazing. They are compact in size, high power density, optimum efficiency and reliability, high speed and torque, and high operating pressures. The third type is the hydraulic vane pump. The vane pump finds its use in die casting and injection molding for machines in industries. They are used in land and road constructions as well. And hydraulic vane pumps operate with much lower flow pulsation, meaning as constant flow. As such, vane pumps produce less noise, maintaining a relatively high speed. So the 4 points would be low flow pulsation, very low noise level, wide range of speeds, and wide viscosity range as well.
Pressure is a type of stress characterized by its uniformity in all directions and is measured as force per unit area. But based on the formula, pressure is directly proportional to force and indirectly proportional to surface area. Hence, pressure increases as force increases and pressure increases as the surface area decreases. Pascal's law states that an increase in pressure at any point in a closed fluid container will result in an equal increase at any points existing in the container. Pascal's law can be demonstrated by making a few openings in a closed toothpaste tube. At any point to which pressure is applied on the toothpaste tube, the toothpaste will come out equally from all of the openings. Pascal's inventions include the hydraulic system and the syringe. On this board is an image of a simple hydraulic pump. A simple hydraulic pump consists of two piston components and a closed fluid container. Having force acting on one of the pistons will cause an equal pressure exerted throughout the whole closed fluid container. For example, the pressure exerted in piston B is 2 kg per meter cube. In any point in this container, the pressure applied will also be 2 kg per
아씨, 그게 존나 또. I'm sticking the glue and make it stand properly. I'm making these two parts stand, and when I push the bottom side, go up like this.
On what principle does it use?
Basically, an enclosed fluid under pressure exerts that pressure throughout its volume and against any surface containing it. That's Pascal's principle, and it allows a hydraulic jet to generate large amounts of force from the application of a small force.
When you're moving in a car, you possess a certain type of energy. This energy is known as kinetic energy. The way you calculate kinetic energy is by multiplying mass and velocity. And the more mass you have and the higher your velocity, the more kinetic energy you have, essentially. That's all well and good though, until you think about cars nowadays. Modern cars are getting heavier and heavier to accommodate for better safety, and also have a higher power output, so you get more velocity and you get more weight. So the kinetic energy in modern cars are ever increasing. Well, that's all well and true until it comes to the topic of stopping. To stop a car that has a really high amount of kinetic energy, you need some really powerful brakes. And the way we employ powerful brakes using only the force of a pedal is by using hydraulics. So in your everyday car, when you go to hit the brakes, you're actually activating a type 2 lever at the brake pedal that pushes down on a small piston. Now this small piston puts pressure into the hydraulic system that flows into the brake calipers that are on each four wheels. And when you get to the brake calipers, they have a much larger surface area piston compared to the piston at the brake pedal. So this causes the force applied to the brake pedal to get multiplied many times over. Causing the friction material to clamp down on the disc brakes in the car, thus creating a lot of friction and turning all that kinetic energy into heat, essentially bringing the car to a stop.
Are a common fixture at any major construction site. They're pretty hard to miss, and they often rise hundreds of feet into the air and can reach out just as far. So what is a tower crane? Tower crane is a piece of equipment used to move or transport oversized objects. It is a stationary device, which means the base of the crane does move. Sometimes tower crane can be seen paired with what is called climbing forward, as can be seen in the two pictures. So climbing forward is a special type of formwork for vertical concrete structures that rise with the building process. While relatively complicated and costly, it can be an effective solution for buildings that are either very repetitive in form, such as towers or skyscrapers, and it can reduce manpower and time. So there's many types of climbing formwork. which usually works based on the principle of hydraulic jacks. Now I'm going to talk a bit more about tower crane, but first let's talk about how tower cranes grow. So basically, a tower crane has a few parts. Firstly, the base, followed by the mast, and a more close-up for the upper part is the slewing unit and the machinery section. So how do tower cranes grow? When they arrive at the construction site, the crew uses a mobile crane to assemble the jib and the machinery section and places these horizontal members on a 40-foot mast, which is here. It consists of two sections. So the mast will rise from a firm foundation and it's very large. To rise to its maximum height, the crane grows itself one mast section at a time, and the crew uses a top climber or climbing frame, as shown in the diagram here, that fits between the slewing unit and the top of the mast, which is here. So the crew will hang a weight on the jib to balance the counterweight here, and when the crew detaches the slewing unit from the top of the mast, the large hydraulic rams will push the slewing unit up 20 feet. The crane operator uses the crane to lift another 20-foot mast section into the gap opened by the climbing frame. Once bolted in place, the crane is 20 feet taller. So once the building is finished and it is time for the crane to come down, the process is reversed. The crane disassembles its own mast and then smaller cranes disassembles the rest. Hydraulic part comes in. At the climbing frame here, as you can see, there's a small hydraulic ram which pushes the mast section, and so this is just a diagram of it. An actual hydraulic ram looks like this.